Hi, my name is Artyom. In this assignment, I solved two problems using CSCP, constraint satisfaction problems. So task 1 is a crossword solver. Task 2 is a university exam scheduler. Let me walk through both of them. So in the task 1, we have a crossword grid and a list of words. The goal is to fill the grid so every word fits correctly. So right length and the letter match where words cross. So this is a classic SCP, and variables are the slots in the grid, domains are the available words, and constraints are the rules words must follow. So first it's enforce node consistency. Here it's algorithms. So the first step is node consistency. We go through every slot and remove any word that is their own length. So a 5-letter slot can only have 5-letter words. So then revise function. This function checks two overlapping slots, x and y. Where they cross, the letter must match in the center. We check every word in x, and if there is no word in y that matches at that position, we remove the word from x. If we removed anything, we return true. So then AC3, and AC3 is the algorithm that revise on all pairs of overlapping slots. We put all pairs into a queue and process them one by one. If after revising a domain becomes empty, there is no solution. If we removed word from x, we add x neighbors to the queue to check again. So here, queue append, and etc. So then we use MRV heuristic, minimum remaining values. We pick the slot with the fewest words left in the domain. If there is a tie, we pick the slot with the most neighbors. When we pick which word to try first, we use the least constraining heuristic. We try words that block the fewest option for every slot. So then we use backtrack here. So this is the main search. We pick a slot and try each word in order and check if the assignment is still valid and recurse it. If a word causes a conflict, we delete it and try the next one. If nothing works, we return none and go back to the previous slot. So let me show you how this works. For example, I put this, run this, and here intelligence, minimax, search, inference. Task 2 is about scheduling university exams. We have students, instructor, classrooms, and time slots. We need to assign each exam a time and a room without breaking 4 rules. Rule 1, no student has 2 exams at the same time. No instructor teach 2 exams at the same time is the second rule. Rule number 3 is a room must fit all students. Rule number 4, only 1 exam per room per time slot. So first, this one is the setup of CSCP. First we load the data and build lookup tables. Then we see on look at course students. It tells us which students are in each course, and course instructor tells us which teacher runs it. So classroom capacity tells us about the room size. So then we have function count conflicts. So this the cost function counts how many rules are broken in a given schedule. We group exam by time slots, then check every pair of exam in the same slot. We count chairs, students, same instructor, double book room, and rooms that are too small to fit all students. The total is the number of conflicts. 0 means a perfect schedule here. So then we have initial schedule here. We start from the original schedule in the CSV file. We calculate how many conflicts it has, and this is our starting point before optimization. So then we have simulated annealing. We use it to optimize the schedule we use, so this function. So the idea is that take the current schedule, randomly move one exam to a different time and room, and check if it's better. If it's better, we always accept it. If it's worse, we sometimes might accept it. So this will help us to escape dead ends. The probability of accepting a bad move decreases over time as the temperature drops. So what is the temperature? Temperature is just a number that starts high and goes down each step. High temperature means we explore more, and low temperature means we only accept improvements. Then we have a function here, this one. We evaluate an expert. After optimization, we compare the initial and optimized schedules side by side. How many student conflicts, how many instructor conflicts, how many room conflicts, and capacity violations. Finally, we save the optimized schedule to a CSV file with all the details, course name, day, time, building, and room. And here it's optimized. We just put it in data frame and print it. Let's run it. So as we can see, everything is working. Initial conflicts, the starting point, almost 8,500, and then after optimization 8,076. Improved by, here is all the events, so everything is worked correctly.